name is Päivä Kinnunen, and I'm the principal investigator in this CCC project. Our work deals with carbon-conscious construction materials. Cement is a wonder material. We can find it anywhere around us in the urban environment, and it is a wonderful material. There is just one problem. It is responsible for a lot of CO2 emissions in the atmosphere. Up to 8% of all the CO2 emissions in the atmosphere is because of that one single product manufacturer.
There's about 10 people working on the topic, and specifically on magnesium cements, which is an alternative way of envisioning how cement could work. And that offers the possibility of not only cutting the CO2 emissions to zero, but even to negative. And there's some fundamental questions in science still open that need to be answered before that can be achieved. And so we are, in this project, we are looking at two of them. And basically we are working, I will show you two examples, dealing with acetic acid and how acetic acid or acetates, how they change the reaction.
Hello everybody, my name is Harishankar and I'm a doctoral student working under the supervision of Fibre in Oulu University. Basically, I try to understand the influence of acetate ligand during the formation of nesquihonite from a completely soluble salt of magnesium and completely soluble salt of carbonate. And I have found some interesting results, which is that in SEM analysis, the particle size is found to control the size of the nesquihonite crystals. For example, as shown in this figure, the particle size were quite large in the absence of acetate ligand, but as we increase the concentration, it kept decreasing, and then further increase in the concentration of acetate ligand led to increase in particle size. We also did some XRD analysis, which revealed that there is some changes in the lattice parameters. So which means that there is a possible substitution of a carbonate group by bicarbonate and hydroxyl group.
This is Mina Qane, PhD student in University of Oulu, supervised by Fibre. In our project, we consider different reactions of HMC structures by DFT calculations and molecular dynamic simulations by vast software. And in the first part of my project, we consider hydration of MgO cluster to see how to accelerate dissolution of MgO and increase production of MgOH2 or brucite available for carbonation. This is a molecular dynamic simulation of water around MgO cluster, and we see movements of water around this cluster. And as you see in the movie, after a while water is connecting to the cluster, and hydrogen is connected to oxygen of MgO, and from other side oxygen of water is connected to the magnesium of MgO, and it is dissociated, and we can see the dissociated structure in the last frame of this movie.
So as a result of this project, we hope to learn more of how these acetic acid and how these ligands work, and then utilize them better, and then also design better ligands to improve on these cements and make them better.